Section 2.5 is reasoning in algebra and geometry. So the first thing we want to look at are properties of equality. Now these are algebraic properties that you should be familiar with. And I'm going to let you take a minute, pause the video, and write these down, and then come back. Okay, so the addition property simply says that if A equals B, then we can add the same quantity to both sides and they will still be equal. Subtraction property works the same way. If two things equal each other, we can subtract the same number from both sides. Oops. Multiplication property, same thing. If A equals B, I can multiply both sides by the same value, and the same with the division property. The only caveat here is that C cannot equal 0. We cannot divide by 0. So these are all things that we can do to both sides of an equation. That's why they're called properties of equality. Oh, I keep skipping. There we go. The next one is the reflexive property. Simply says that A equals A. In other words, if I have the same thing, it equals itself. Symmetric property. We also sometimes think of this as the commutative property, but the symmetric property refers specifically to two values. If two values equal each other, then you can say that they equal each other in either order. The transitive property. If A equals B, and we know that B equals C, then we can say that A equals C. And substitution, if A equals B, then you can put B in place of A in any expression. These should be pretty self-explanatory, and there's things that you used in algebra. So let's take a look and see what we want to do with these. Oops, we have one more property to look at, sorry. The distributive property, written like this, go ahead and copy it down. This may be a new symbol to you. It means plus or minus. Can't remember if we did that in this class yet or not. Plus or minus. And all it means is that it's a shortcut way of saying if we have A times B plus C equals AB plus AC, or A times B minus C equals AB minus AC. So plus or minus, either one works. That's writing it out the normal way. That's using this little shortcut notation. So these are the properties we're going to be working with. So, justifying your steps when you're solving an equation. Let's say, whoops, where'd we go? Okay, back it up. Here we go. All right. So let's say that we have a diagram that looks like this. And I'm going to call this angle AOM. And this angle will be MOC. And this angle on the left is worth 2x plus 30 degrees. And this is x degrees. So I have two angles, and I want to use a proof or use justifying steps to find out the value of x. What is x? So I have to do a couple of things. The first thing I have to do is say that angle AOM and angle MOC are supplementary. Without saying that, I can't talk about adding these angles together to get 180. And so the reason for that is that angles that form linear pairs, come on, are, I don't know why this isn't writing well, are supplementary. So I've shown that those are supplementary angles. The second thing I'm going to do is say that therefore the measure of angle AOM plus the measure of angle MOC equals 180 degrees. And that's the definition of supplementary angles. Okay, the next thing I'm going to do is I'm going to say, well, the measure of angle AOM is 2x plus 30, and the measure of angle MOC is x, so those equal 180. That's by substitution. The next thing I'm going to say is that 2x plus 30 equals 180. That's the commutative property. We didn't have that on our list, but we should all know it. Commutative property of addition. Okay. And then I can actually do that addition. 3x plus 30 equals 180. And that's basically substitution. We substituted 3x in place of 2x plus x. The next thing I'm going to say is that 3x equals 150. That's the subtraction property of equality. If I subtract the same thing from both sides, in this case I subtracted 30. And the last thing is that x equals 50. And that's the division property of equality. I can divide both sides by the same number, and I divided by 3. And so I've shown that x equals 50 by these steps and showing these particular reasons for my steps. So that's what we're going to talk about in a moment. But first of all, we need the properties of congruence. These are similar to the properties of equality, but these have to do with our geometry. So the reflexive property, first of all, pause and write this down. Okay, the reflexive property says that if AB is congruent to AB, in other words, it equals itself, or angle A is congruent to angle A, it equals itself. Symmetric, same as our symmetric property of equality. If AB is congruent to CD, then CD is congruent to AB. And the same thing with angles. You notice we're doing line segments and angles both. And the transitive property. If AB is congruent with CD and CD is congruent with EF, then AB is congruent to EF. Can do the same thing with angles. And you notice I've done it a little bit different way here. It doesn't matter which one I put first, because by this property I can switch the order and it's still the same thing. So those are our properties of congruence for geometry, similar to the properties of equality. So now we're going to use these properties. First thing I want to use it on is this example. 2x plus 9 equals 19, and I changed to 2x equals 10. What property did I use? Okay, hopefully you found it as the subtraction property of equality. How about this one? What property is being used there? Look back at your properties of congruence and restart the video when you think you know. Okay, this is the transitive property of congruence. And the last one, what do you think this one is? And this is the symmetric property. Oops, that's supposed to be a C. Symmetric property of congruence. Okay, so very simple examples of how to use these properties to explain how I can go from one step to another. All right, a proof. A proof is a convincing statement that uses deductive reasoning, and a two-column proof is one method of showing a proof. So draw this diagram and write down the fact that we are given in the diagram that measure of angle 1 equals measure of angle 3. So write all that down and come on back. Okay, what we want to prove here is that measure of angle AEC, let me get a different color of ink. We want to prove that AEC is congruent, or I'm sorry, actually equal to, let's see if red will stand out, BED. So I'm going to prove that those two angles are equal. And we're going to set up a two-column proof. We're going to have a line with a column with statements and a column with reasons. So let's get going on this. The first statement I'm going to write is always the given. You must always write the given first. So measure of angle 1 equals measure of angle 3, and the reason for that is given. Number 2. Next thing I'm going to write is that the measure of angle 2, and the reason I'm doing this, I'm looking at AEC and I'm seeing that it's 1 plus 2 and BED is 2 plus 3. So I'm adding 2 to both of those angles. I'm going to make use of that. So I'm going to say that the measure of angle 2 equals the measure of angle 2. And what's the reason for that? The reflexive property of equality. Step 3. I'm going to say that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 2. And I hope you know that this is the additive property of equality. I can add the same thing to both sides. All right, let's look at step 4. So now I'd like to substitute our values in here, but first I have to state that measure of angle 1 plus the measure of angle 2 equals the measure of angle AEC. And in the same step, because it's the same reason, I can say that the measure of angle 3 plus the measure of angle 2 equals the measure of angle DEB. And that is because of the addition postulate from our previous work. And we're going to write down a list of our postulates. Whoops. The addition postulate for adding angles together. Whoops, that's reason 4. Okay? Step 5. I'm going to say the measure of angle AEC is equal to the measure of angle DEB. And that's through substituting into equation 3 our two equalities. So that's simply substitution. Okay, so get that all written down, take a look at it, and we will do another one of these in a moment. Whoops, back it up. So I want you to do one more here. I'm going to give you another diagram. Oh, come on. Well, let me see. Let me go back to my last screen. Come on. Okay, let's try this again. If I draw you a diagram here of, whoops, I want that as an endpoint. So I've got A, B, C, D. So the given information is that segment AB is congruent to segment CD. And you want to prove that segment AC is congruent to segment BD. So write yourself a two-column proof, your statements and your reasons, and see if, starting with the given information, you can come up with a two-column proof for this. And we will do this in class together when we go over our notes. All right, so that's it for today.